Okay, so we're coming up on about 2/3 here, having participated. So I'm going to give you about another 30 seconds here. If you want to try and get your answers in. Okay. So person who private messaged me, give me a second and hopefully I'll be able to answer your question. Let me end the poll here and share the results with you. Okay, I mean, like it, so we're definitely leaning towards A here. What I want to do is I want to give you another shot at this, but let's figure something out first, okay? So we're compounding every 5 days, right? That's what the question says. So how many compounding periods happen in 1 year? Okay. Okay, yeah. So somebody tell me how you all got 73. Why is 73 the answer? Exactly, it's 365 divided by 5, right? You're saying, listen, we compound every 5 days. There are 365 days in a year. That means that there's 73 compounding periods in 1 year. Okay, so there are 73 compounding periods in 1 year. I want us to try this poll again, but keep this in mind. There are 73 compounding periods. And I'm going to give you less time to answer the question this time because you've already done most of the work, right? Okay, 30 seconds. And I guess in a sense, like that was a really big hint because there's only one place where the number 73 shows up, but still. Okay. All right, so with our hint, here's where we are now. It's okay, it's okay. Again, this is the time to get it wrong, right? Because you're going to learn from your mistakes here, and that way you don't make those mistakes on a test. So this is exactly the sort of thing that you want to do. So yeah, overwhelmingly, we've now voted A. A is absolutely the correct answer. So let's see why that's the case. Oops. All right. So as a reminder to ourselves, sorry, that might be a little bit loud. Okay. So the question is, we're told that we invest $1,000. So this is question 2. I started us on question 2 today. So question 2. So we have P is equal to $1,000. We are told that we have an APR of 3%. Of 3% compounding every 5 days. All right, and then we do this for 75 days. For 75 days. Okay, so we know that the future value of our account so the future value is S is equal to P times 1 plus R to the N. Okay, now the first thing we have to do is, because APR shows up here, and this is critical, right? You're always kind of looking out for this, these 3 words or this acronym, the annual percentage rate. If we see APR, it means the rate that we're quoted is the rate for the entire year. And if we want the term rate, then we have to divide the APR by the number of compounding periods. So as we said, there are 73 compounding periods in the year, right? There are 365 divided by 5 equals 73 compounding periods. So the term rate is going to be 3% divided by our number of compounding periods. Okay, that's our term rate R. Is that okay? Does everyone see how I managed to compute that number from the information we were given? Right? Like 5 days is weird, right? That's not a thing that really tends to happen in real life. You don't compound every 5 days, but we chose it here because it divides 365 quite nicely, right? Let me ask you, or actually, you know what? I'll ask that question at the end, but let me answer this question in totality first. Now, what is n? Okay, what is n keeping track of here? The exponent. What is this n doing? How do we figure that out? Okay, sure, yeah. So 75 divided by 5, exactly it. And so that's going to end up being 15. If someone had to tell me in words what you're doing when you're computing 75 divided by 5, like what are you actually calculating there? Exactly, the number of compounding periods that we pass through, right? Yeah, exactly. Perfect, everyone. So you knew there were 75 days. So you divided by 5 to figure out that there were 15 compounding periods in that span. Exactly, right? So there are 75 divided by 5 equals 15 compounding periods. Maybe let me just say that that's equal to n. And so in total, so we're getting it S is equal to 1,000, 1 plus 0.03 divided by, what do we say, 73 to the power of 15. And that's our answer. And that was A. So answer A, like that. Okay, does that make sense? Any questions?
There's one raised hand right now.
Yeah, Brandon?
So just for clarification, the 73, that's the number of compounding periods we're passing through in a year.
Right.
Whereas the 15 is just the number that we pass through in this particular question.
Exactly.
Okay. Thank you.
So if we'd said like, what's the value of the count after a year, then the exponent would have been 73, right? Or if we'd done like 100 days, then the exponent would be a 20 because there would be 20 compounding periods in 100 days. If we'd said 2 years, what would the exponent be if we did this after 2 years? What would the account be? How many compounding periods? Yeah, exactly. 73 times 2, so 146 periods, right? Because after 2 years, we had 73 periods in each year. And then, so after 2 years, there would be 73 plus 73 compounding periods, right? So we'd get 146 periods. All right. Now, let me ask you on the flip side, here's a weird question. What if we compounded every 73 days? What would our number of compounding periods be? If we, yeah, exactly. Connie, so quick. Yeah, there would be 5. Right? So you can imagine I could give you a question, which what if I said the exact same question, APR of 3% compounding every 73 days. And, you know, what is the value of the account after 2 years? In fact, let's like very quickly. So let's say compounding 73 days. So same question, compounding 73 days after 2 years. After 2 years, then S is equal to what? Write it in the chat. Yeah, perfect. Anaga, you're probably missing your exponent there. Okay, Junshi, you want to be careful, right? So if we're compounding every 73 days, then we only have 5 compounding periods in a year, right? 10, right? Sure, yeah. Okay, yeah. So the power of 10 is the one you want. Yeah, Karen, perfect. Exactly. Beautiful. Exactly. So 1,000 1 plus 0.03 divided by 5 to the power of 10. Okay, so are there any more questions about this? Like, if we change the question around, do we see how we would actually assemble that information? Like, now is a good time to ask questions, because again, this sort of thing is fundamental. It's very integral to everything that we're going to do. Why is it 10? Okay, so the 10, because there are 5 periods in a year, in 1 year. And then I said to do this for 2 years. So that means that there are 10 periods. Right? Does that make sense? It's like if I said monthly, this would have been a 24, right? Because there are 12 months in a year, but after 2 years, there are 24 periods, right? Okay, sure. So why did we divide before, like the 5 here? So that's because when you're given an APR, you have to figure out the term rate by dividing the APR by the number of compounding periods in a single year. Right? So if you compound every 73 days, there are 5 compounding periods in the year. So you take the 0.03 and you divide it by 5. No, the exponent in the previous question, we did 75 divided by 5. Right. And that was because we were trying to figure out how many compounding periods were in a year. So alternatively, let's try it like this. We said there are 10 periods in the year. So how many days is that? That's 365 times 2. So that's what? 730? Right? So we could get it that way as well. Right? But in this case, because it was a nice multiple, right? We knew there were 5 periods in a year. 2 years tells us 10 periods. But we could have said, oh, there's 730 days in 2 years. If we divide that by 73 days, we would get 10 periods as well. So we could do it either way. But I think it's good to be able to look at the problem holistically and say, oh, I can see that there are this number of periods in a year. So after 2 years, there'll be this many periods, right? So I think being able to do it both ways is pretty important. Why we got 5? 365 divided by 73, right? This is the number of compounding periods in the year, and that works out to be 5, right? So here, let's think about it like this. So here's our year, and our year is broken into 73-day chunks. And if you check, that means that your year is broken into 5 pieces. You know that you need an interest rate of 0.03, but that's spread out across these 5 chunks. So each of these chunks have this much interest on it.
0.03.
Oh, sorry, 3. Yeah, thank you.
Yeah.
Right? So we take our year, we divide it into chunks of even size, and then we take our APR interest rate and we also divide that into equal chunks. And so that's where those numbers come from. Okay? Is everyone good? That makes sense? Again, because this is a fundamental thing. So I want you to be able to do that. So I'm very happy to spend lots of time on that. All right, let's try. Oh, I was going to do this question first. Maybe we'll skip that question. I'll go back to it if I think we need it more. Oh, no, let's do this. Okay, so let's practice then. This is the easier question. I feel like I actually probably should have started with this. Or maybe it's not as easy. Actually, now that I think about it, maybe it's not as easy. Let's find out. I think maybe it's nicer in the sense that the numbers work out to be a little bit better, but
I agree with that. That's fair. The numbers are a bit nicer, but same principle.
Exactly. Yeah, I think I'm recording right now. It actually probably shows up on your screen, Hamza. You probably should say recording in the top left corner or something. But you're right, I should pause during this point because it's kind of boring for the watcher. Exactly. Thank you, Kaylin. Okay, so let's stop this here and pool, share results. And pretty overwhelmingly, right, we answered D, and D is absolutely the correct answer. So good job. And if you don't see why it's D, let's talk about why that's the case. So this is question 3. Right, so we've got $10,000. That's going to be our principal P. And then we've got, what do we say, an APR of 4% compounded monthly. So APR of 4% compounded monthly. So, the thing is, in this question, I actually, we filled in a lot of it for you, but in theory, you should have been able to do all the parts of it, right? So APR 4% compounded monthly, and then over 2.5 years. 2.5 years. Okay. So once again, we've got S is equal to P times 1 plus R to the power of N, right? R is going to be our term rate. So we're going to take that 4% over the entire year, and we're going to break it into how many even chunks, how many compounding periods are there in a single year? Yep, right? Everyone's okay. There's 12 compounding periods in a year. In 1 year, right? So R is going to be 0.04 divided by 12. We're going to take that 4% of interest and we're going to spread it up. Yeah, you only divide it if you see APR, right? So if you don't see APR, then the rate that you're quoted is actually the term rate. But if you see APR, you're being told how much interest there is over the entire year, and then you have to split it up into all of the chunks, okay? All right, so that's that, and that already tells us that the answer is either C or D, because this is the denominator there is A. Now, in 2.5 years, we need to figure out how many compounding periods there are. So how many are there? So in 2.5 years, there are exactly N equals 30 compounding periods. Right? And you could do some sort of thing where you're like, okay, let's see, there's 12 months in a year, 24 months in 2 years, and then I got another half, so I need to add in 6 more, so that's 30. Or you could just do like 2.5 times 12, right? And that would give you the same number, right? So that's our answer. So the future value, even if we did this kind of without a bunch of the stuff being given to us, is 10,000, 1 plus 0.04 divided by 12 to the power of 30. Okay, so that tells us that the answer is D. Okay, any questions? That's okay, that makes sense, hopefully. Okay, and again, if you're typing something, you can just, keep typing. We'll come back to it. Let's do this one then. Let's see how this goes. Yeah, let me go back. I'll go back after this question is done. Okay, and then you can see it. But don't forget, I also post the questions, so we'll be able to do that as well. But yeah, I'll go back as soon as this one's done. And Karim, I wish you'd said something earlier. Yeah, no, absolutely, you're right. I missed that entire question because I forgot to unpause. Next time you see me screw up like that, just remind me, right? So the question's on the screen now, so it'll show up on the recording. I am going to pause. So I'll give you about, or sorry, 2/3 have voted. We're at about 66%. So I'll give you another 30 seconds.
The polls are very split.
Very split. All right. Okay, Jack, that's great. All right, so you can see we're pretty damn split here, right? And in fact, C is winning. Let me ask you the following: how many payments are left? It's November 1st. I'm giving you back $10 a month. How many payments are left? Right. Okay. There's 2 payments left. So that means that there are 2 payments that you need to bring to November 1st, right? Does that help narrow down what the correct answer should be? Like, does it? No. How many $10 things occur in answer C? Yeah, there's 10 of them, but how many payments are left? There's only 2. All right, let's try this again. I suspect we might get a 50-50 divide between A and B, but let's see if we can refine it a little bit further. Right. Yeah, exactly. Brandon, that's a phenomenal way of looking at it. C is the value of the debt that has already been paid. Sure. Yes. Yeah, that would be fair. Yeah, that's a great way of seeing it. Oh, wow. This is great. Once I took C out of the equation.
I've seen a lot of people pick C because it had a sigma and it looked scary. So they just kind of like inherently went for it, thinking it would be the answer.
But then I figure that those people would evenly distribute between A and B, but overwhelmingly they're choosing the right answer. So
that's very fair.
Mm-hmm. So Emma, negative K for C, if it was the value of the debt already paid. Well, so in November, the payments have already occurred. So what you're computing in that sum is the total value of all of those payments as of November 1st, right? And because November is ahead of those payments, for example, one of those payments is the March 31st payment, it's actually being pushed forward in time to November, right? So in that case, the exponent is positive. Okay, so I'm going to close it like 20 seconds here because you avoided C for that reason. That's nice. Because there's 12 payments and C has 10 of the payments, right? So there's 2 payments remaining. C is already computing how the future value of the first 10 as of November 1st. Okay. All right. So, and again, this is very surprising to me. I don't know if this was guessing, but once we kind of eliminated C, overwhelmingly everyone put A, and A is absolutely the correct answer. So that's great. Like, that makes me happy. I'm confused. I don't know how we went from C. Again, I thought we would be split on A and B, but almost everyone went for the right answer, which is great. So let's talk about why that's the case. So this is question, what question is this? 5? 4. Oops. Okay, so question 4. Okay, so again, kind of without rewriting the entire setup, so we have $10 payments. On what, November 30th? November has 30 days, right? November 30th and December 31st. Did I get the number of days in each month correct? Somebody double check that for me. 30 days has it in September, April, 30 days has September, April, June, and November, yep. Right? I think that's right. Said, okay, so I think these are right. And then we compound at an interest of 5% monthly on the 28th of each month. So we've got an APR of 5% monthly compounding on the 28th day. And you can see here, we were very precise about what day the compounding events occur so that you know whether or not they occurred, before or after the actual payment. So let me, again, draw a timeline, right? Timeline's going to save your life. So we're going to draw out a timeline. So here's November 1st. Here's November 30th. And here's December 31st. Okay. And we are going to compound. What did we say? 5% compounded monthly. So here's a 0.05 divided by 12 compounding event. And here's a 0.05 divided by 12 compounding event. And then there's going to be $10 here, a payment of $10 here, and a payment of $10 here. Does everyone agree so far with the timeline that I have drawn? Is everyone okay with it? Okay, right? There's $10 payments at the end of the month, but the compounding event occurs on the 28th day, so just before the end of every single month. Okay, so if you're not okay with that, scream and be like, yo, that doesn't make sense. Okay, so what we're going to do is we're going to compute the present value of each of these payments. So the first thing I'm going to do is I'm going to take this $10 on November 30th, and I'm going to bring it back to November 1st. And when I do that, how many compounding events do I pass through? Exactly, just one. So this is going to be 10 times 1 plus 0.05 divided by 12 to the power of -1. Everyone agree? Does that make sense? Okay, beautiful. Now I'm going to take this $10 and I'm going to bring it back to the present. And when I do that, how many compounding events do I go through? Look, I swear I didn't even finish the statement and already people were typing 2 into the chat. That's wonderful. So 10 times 1 plus 0.05 divided by 12 to the -2. And then, you get both of these payments. So the answer is to add them together. So the total value is their sum. I would not, I know some of you might be tempted to factor out one of these 1 plus 0.05 over 12 terms. Please don't do that. Just leave it like this. Yeah, right? Timeline, big difference maker. Remember last week when I was like, draw the timeline, it makes a huge difference, right? This is answer A.
-2, not -12.
Oh yeah, I'm sorry, thank you, -2.
I can tell you one thing, like, I did my specialist in finance, and I'll tell you these timelines become like a gem for you down the line. Like it gets even more and more important the more you do finance. So I cannot recommend them enough.
Yeah, and you can see what's happening then, right? I think like instead of trying to visualize the time in your brain, like don't hesitate to write these things down. Now I want to kind of warn you, right? Like this is not, yeah, Karen, let me answer that in a second. These are not the sorts of things, like you couldn't write this down and have it presented as a solution, right? Like we would not accept this as a solution, but 100% you could use it as a visual guide. So you can do that as well. In terms of what I'm actually writing on, so I'm just writing on a Surface, a Microsoft Surface. This is OneNote, and I'm just using like a pen. I actually do have an iPad here. It is my backup in case everything explodes. So in the case that everything explodes, the Surface will become my main computer, and then I will write on the iPad. So that's actually what I'm using. Can I explain why I add them together? Sure. If like there's 2 payments here, right, Junshi? So like there's a payment on November 30th. That's worth something to me. And then there's a payment on December 31st, and that's worth something to me as well. And what's the total value of what's that worth to me? Like think of them as being 2 different bank accounts, right? One bank account holds the November 30th payment. One bank account holds the December 31st payment. You own both bank accounts. If I said, how much money do you have total? You would add them up, right? Yeah, so that's why you add them. Why is it -1 and -2? Okay, so Sylvia, the -1 here comes because we only pass through one compounding period. The -2 is because when I took this December 31st payment back, it passed through both this one and this one, okay? So it came back through both amounts, right? And so because it came through 2 compounding periods, it has a power of -2. Does that make sense? So the question is asking, the question is basically, you're standing here, right? This is you. And you're there are these payments occurring in the future, one at the end of November 30th and one on December 31st. And you're trying to figure out what are those values worth to you today. Okay. What is the combined sum of those payments worth today? If the payments are done till November, why K is not negative? They aren't, but they are negative. I'm not certain what you're asking. Right? Because it depends on what the K means. I assume you mean the exponent, but the exponents here are negative, right? Oh, for option C is a different thing. Okay. If you want to see the option C, right, you've got like January 31st or whatever, January, February, the end of February. All right, maybe let me write it like this. So this section is January, February, March, April, May, June, July, August, September, October, November. March, April, May, June, July, August, September, October, November, right? And you have now payments of $10 on each of these months. So you got $10 here, $10 here, $10 here, $10 here, $10 here, $10 here. Actually, it might only work out to be 9. We're gonna have to check here. And then you have compounding events here, 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 and here. And so what you're gonna do is you're gonna take each of these things forward in time. I should start on the other side, right? So you can take, boop.
Tyler, I'm just gonna hop off here to go start the tutorial.
For sure. See you later. Thanks, Aziz.
No worries.
Okay, so when you're actually pushing them forward in time, this is how you do it. You can see that obviously it's much more complicated, but you would push each of these things forward in time and compute how many compounding events you get through. With November 1st, actually, I guess November 1st is right here. So I guess, sorry, I kind of like made them go too far. But you can see we're pushing these payments forward in time. And so because these payments are being pushed forward in time from when they occur, then the power of the exponent is actually positive. If I wanted to see what the value is today, wouldn't you just do 1 plus both compounding periods? Yeah, sure. Let me just pull that up for you in a second and then I'll read the chat. Okay, so I assume that 120 is actually 12 and closing bracket, right, Kurti? Like that's what that was supposed to be. Okay. So that payment, what you wrote down is this number right here, right? That is the $10 that was paid on December 31st. And it does include both compounding periods, exactly like you said. However, there's another payment right here. And this payment, right, is not included in the equation that I've squared off here, right? The square equation is this payment right here, right? And only that $10. Does that make sense? Right? So if I said, listen, forget about it, there's no $10 payment on November 30th, then the answer would be just that. That would be the answer, right? But there's another $10 payment. So we have to take that $10 and bring it back to now as well. How do we know if it's a future value or present value, if the exponent is positive or negative? So it depends on where you're taking it. If you're taking money and you're moving it forward in time, you're going to have a positive exponent. And if you're taking money and you're moving it backwards in time, then you're going to have a negative exponent, okay? So for example, let's say I drew a timeline and we did some sort of crazy thing, right? And we're standing here. So we're trying to move money to here. And let's say I've got like a principal here, I've got a principal here, I've got a principal here, a principal here. And let's say I had, like compounding events like this. If I were to bring this payment back to the present or back to you standing right here, this would be P times 1 plus R to the -1, right? Because I've moved it backwards in time. If I were to take this payment and move it forward, then because I'm moving it forward in time, it would be P times 1 plus R. So positive, like when you move money forward in time, it has a positive exponent. When you move it backwards in time, it has a negative exponent. Does that make sense? Okay, perfect. You sell the debt. Okay, this is actually like this is a really like, dude, this is a great question. So debt is a security, right? Like 100% people operate, buy and sell debt. In fact, that's what bonds are, right? So what will often happen, and corporations will do this, a corporation might do something like, I need to generate a lot of money really, really quickly. So what I'm going to do is I'm going to sell you debt. And what that means is so let's say I'm the company, okay, I'm Apple, and I need to raise money for whatever reason. So what I'm going to do is I'm going to ask you to give me $1,000. And in return, I now owe you a debt, right? You gave me $1,000 and I owe you a debt. So you've got this little piece of paper that says, Tyler of Apple Corporation owes me this much money. And that amount of money, right? You gave me $1,000, but that IOU I gave you is not worth $1,000, right? It's actually worth less than $1,000 because if I decide not to pay you back that money until 12 months from now, we know that the time value of money says that $1,000 12 months from now is worth less than $1,000 today, right? So you, at this point, given this setup, you're probably going like, well, why would you ever do that? That's stupid, right? I don't just lend out money for free. And the answer is, you're absolutely right. You wouldn't lend out money for free. You would give me $1,000 and I'd say, okay, well, in 12 months, I'm going to pay you back maybe $1,200, right? So that you make a profit. And then you have to decide that $1,200 12 months from now, is that worth more to me than $1,000 today? You know what I'm saying? And the way that you would actually do that is compute the present value of that $1,200 payment 12 months from now. You would actually bring that back to the present. You'd compute what that is worth to you today. Maybe you'd say, oh, it's like $1,150. That's totally worth more than $1,000. So it definitely makes sense for me to lend that money, right? Because I'm going to definitely make a profit off of this. Exactly. It's an opportunity cost. Now, in practice, what actually happens is you pay me $1,000 or you give me $1,000. I don't offer to give you more money. Okay, so like let's say you give me $1,000 and I'm going to pay it back in a year. Okay, so at the end of the year, I'm going to give you back $1,000. But the way most debt securities work are as bonds. So what I say is every month I'm going to give you $10, right? So at the end of every month, I'm going to give you $10 and then see ya. And then at the end of the year, I'll give you back the $1,000 that you gave me. They're like interest payments, if you want to think about them like that. So that's what a bond is. And those interest payments are called coupons. Okay. And that's how bonds actually work. So when you ever see people talk about bonds, that's what they are. They're debt, right? So municipal bonds are debt taken out by the city. You have corporate bonds. See everyone. Yeah. For those of you who have to leave, obviously leave. There's corporate bonds where corporations have taken out debt and, are going to pay you interest payments, all these sorts of things. Hala, the recordings, if you go to meetings, you'll see beside our lecture, something that says lecture material. And if you click that, you'll be able to see the recording. So if you actually go and just do that now, you'll be able to see them. And then if you can't find them still, just ask me and I can share my screen if I have to and show you where they are. So anyway, so that's debt. And you would imagine people buy and sell corporate debt, right? Like I own bonds like US Treasury bonds, right? So bonds that the US Treasury has sent out. And I mean, they're worth almost nothing because the interest rates right now are so low. But if I wanted to sell those to someone, right, we have to figure out what is that bond worth, i.e., the bond might be a 20-year bond and we might be 15 years into that bond. Well, there's only 5 years of payments left. So we have to actually figure out what that bond is worth for me to be able to sell it, right? What is that bond worth to somebody? And then maybe give them a slight discount to make it even more worth their while. So these sorts of pricing models show up everywhere because that's what, a lot of these debt securities are. You're going to receive some sort of cash payment in the future, and you need to figure out what is that cash payment worth to you today, right? So that's what I mean by selling debt, right? But 100% just think about it. I gave you an IOU that says whoever holds this piece of paper is going to receive $10 from me every month, and you could sell that to someone, right? That would be worth something. See you, Shiyang. Yeah, so that's what I mean by selling debt. No problem. Okay. Okay, so we're gonna go into office hours, but if you can all just give me like 5 minutes, because I've been going here for an hour straight. So let me just give me 5 minutes or so, and I'll come back and I'll answer any of your questions that you might have. Thank you. For those of you who obviously can't hang around, by all means, take off, and I'll see you all on Thursday. And for anyone who wants to hang out for office hours, like I said, just give me 5 minutes and I'll be back here. Okay.